that off the screen. There we go. Hello, nice to see some people out there. So thanks as always for joining me for the live stream. I really appreciate it when you um, are able and choose to do that. It's nice for me to know that someone's there with me on the live stream, and also sometimes it's a way to catch myself if I accidentally switch off the audio or something. So I'm gonna jump right into things. So I sat there for a long time and got all the projects graded because I don't want people to have anxiety about getting those results back. So all the project 2 scores are back. So it's a time to sort of, if you did great, then just keep motoring along like you're doing. If you had any struggles, there's still, there's no reason why you can't come sort of get a better understanding of the things you're struggling with. Canvas inbox, Piazza, office hours. Very few people in the programming algorithms 1 classes do that, but those things are available to you. Don't forget that the drop-in time, which some people are more comfortable with, it's open to everybody. And some people are slightly more comfortable with that, I think. So anyway, please take advantage of the communication channels so that I can help you and or your classmates can help you get past whatever obstacles you're facing. So I have a whole bunch of Project 2 demos that I'm going to run through real quick, which is why there's a million tabs on my browser. So I'm going to go through these pretty quick, but before I do Project 2 demos, nobody wakes up knowing how to program. Nobody on planet Earth has ever woken up knowing how to program. So when you see these demos, if these people did things that you didn't figure out how to do, everyone can learn how to do this. Everybody. It is a craft. It is not, there is a certain amount of artistry that some people employ. I'm not one of those people. It's a craft. It's a trade, and well, the programming part's a craft, and you can make that your trade if you want to. But anyway, it just takes work. It takes repetition. It takes struggling through problems. It takes carefully examining the examples that you have through lab and through lecture. So everyone can do what these people did. Everyone. And so hopefully you will look on these examples from your classmates as, well, if it's one of yours, then props to you for doing something really cool. But you can do these things, and you can always ask if you see something in these demos. Post something to Piazza saying, "Hey, how was that done in that demo?" So everyone can do these things. It just takes practice. So anyway, I have 10 of them, which is a lot for 50-something people that are in my 2 sections. So I'm just going to go through really quickly. And so just kind of pointing out, this one is super clean interface. This person is using the clear screen that was provided to you. They're just employing that function in good play. I'm not going to play guess that number because, well, let me see. Let me see if, so some of the things, and I'll go faster as I move on to other ones. Some of the things to look for in these demos, though, is the information that the person who programmed this system is providing to the user, which right now is me, that helps them. So they're telling me the range of numbers. Super useful. Even though I know that from the project, it's still, you want to be in the habit, if you have a user sitting there interacting with your software, of telling them what's going on and what to do. I have 8 tries. So they're using the pause function here. So I'll just do a binary search. I hope you guys know how to do that. Probably you do. Well, I guess it's 51. So no, back to the main menu. Let's do a rock, paper, scissors real quick. No, and then exit. So this person doesn't have the total plays calculated up, which was achieved simply by summing the counters, but still a very nice piece of work that with really nice output on the screen. So good job. All right, now got to start going faster. So this one, just goodness gracious, this is neat. That kind of thing is doable. I suspect that this person went and did some Google searching and then did a lot of experimentation. So this probably represents a fair amount of effort on this person's part to do something that is this cool looking on the screen. This is not because they woke up and magically had it in their head how to do this. This is because they took the time to figure out how to do it. Pretty cool. So no more number guesser, I don't think. So I mean menu, let me see, because one of the number guesser, oh man, I have to do this again. Some people have difficulty levels, which is, okay, I'm just going to guess and lose. So very nice summary display. They totaled up the games played. This person actually had an extra counter that wasn't required to keep track of how many times they had a bad guess on their number guesser, which is super, super cool. And then they used the pause and the clear screen a bunch to make for pretty output. So that is very nice work. Let me load this one up. Very cool. There's some really cool graphics-y things going on in some of these. This one has a cool theme, and they've got some, see the sparkly things, quite nice. So I guess I do have to do the number guesser. This one's wrapping a little bit too much text across the screen, but not a deal breaker. Too high. Oh yeah, let's just guess them out. Okay. Play rock, scissors, paper. Oops, I was supposed to and this person had a they used my name several times. They had the totals, how many times did I play the things. But notice they took the time just to figure out how to put some extra kind of sparkle, quite literally in this case, and a little bit of theming in their project. So that was a nice one to interact with as well. Let's see, if I can keep this down somewhere around 10 minutes, that'd be good. Yeah, this one's kind of rough because you only get 3 guesses, but I'm just going to lose that. And I'll stop on the one that has the difficulty levels, which was super, super clever. Anyway, that one's just nice, clean output with all the required data in it, so good job. But anyway, it's roughly 10%. Of the project. So this one also did some text graphics, which looks really, really cool. Like a little hello badge, my name is kind of thing. Anyway, that's really cool. And again, everyone can figure out how to do this. It's a matter of whether or not you take the time to figure out how to do this. But now you know you have classmates who figured out how to do this, so you could use Piazza to ask them, how did you do that really awesome thing in your game? And maybe they'll tell you. Question marks. Anyway, just really cool. Is that one going to make me go forever? No. Okay. I'm losing on purpose so we can just kind of see rock, scissors, paper. Quite cool. Oh, wait. Do I type 0 to... Yeah. How do I get it? Oh, this one might have got stuck here, which is okay, but I wanted you to see the graphics. So not all of them are absolutely perfect, but it's really cool that people had the courage to go out and figure out how to do something special with their projects, which is quite cool. One of these... Yeah, so I'm just going to lose on purpose. So a handful of people had this idea, which was fine and kind of cool. they had a best of 3 rock paper scissors game, which is neat. Rock, 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 and notice, so they show what I played. They, instead of saying the computer, they gave the opponent a name, and then displayed the result. Boyd wins. I won all 3 rounds in this case, which is pretty rare, actually, that I managed to do that. Run from Soren. So anyway, the totals had a little bit of theming in it. So anyway, that was an enjoyable one to interact with. Almost down to the end of them. And hopefully I saved some of the ones that implemented difficulty levels in the number guesser, which I thought was cool. Okay, so let me just lose. Nice, though. That's nice looking output. Anyway, so that one's just a good, straightforward, clean display. All of the requirements are met. The totals showing wins and losses, which are kept in separate counters. That was very nice work. All right, so let me just lose. So back to the main menu. So this person had some sub-menuing, which was kind of cool. They also told me what the right number it was at the end, which is a nice touch. So I like that. Rock, paper, scissors. So again, this one sort of says what I played, what the computer plays, and then a display detailing the results. So rock beats scissors, you win. I'm going to go back to the main menu, and then I'm going to leave the program. And this one has some totals going. So that was another one that just good, clean display. Could have used the clear screen and the pause to make that even prettier, but still it met all the requirements and it was nicely done. So good job. There's another one, I think maybe one more with graphics in it. And it's... maybe I didn't pick the ones with the difficulty levels in it. Yeah, so another one is just kind of clean, meeting all the requirements and nice to interact with. Okay. Oh yeah, this is the one. So these are just characters on the screen, and it's relatively easy to do, and it is very easy to find how to do on the internet. So look, they put in my name inside of the Game Boy, which is really cool. Pretty neat little touch. In there, they managed to kind of cram in the menu inside of the Game Boy, which is really cool. I'll play the number guesser here. This one has a difficulty level as well. So this person's really showing off their chops. I'm going to go 1 for the easiest. Oh, 20 guesses. Oh, dear. Well, let me just go ahead and then play. 2 for rock, paper, scissors. They've got graphics. We call these ASCII graphics, ASCII, ASCII graphics. Relatively easy to do once you figured out how to do it. 3 to stop playing. And anyway, there's a game over screen. And I'm glad this one just kind of randomly ended up as the last one that I showed. Just to kind of show off the level of effort that some people put into the project. This is the kind of thing that I think you could probably show off to friends and or family. Or other interested parties that would think that what you're doing is kind of a cool thing. So anyway, for inspiration, you all can have the ability to do this. If you've come this far in the class, you can do this. It's a matter of giving yourself ample time to work out problems. It's a matter of giving yourself ample time to do some research for yourself and ask questions. How do I do this thing in Golang? Google is pretty good about finding specifically what you're looking for with any kind of wording to the question that you might come up with. So just type in your question in Google and add Golang at the end, and many of these things will just appear that will help you figure out how to do this stuff. Anyway, that was a very cool one. And those were all the very nicely done projects. And those weren't the only ones. Those just as many as I thought I could squeeze in a not unreasonable amount of time. So good stuff. The first thing I'm going to do, so anyway, switching over to oh, I forgot on my agenda. So some general tips. A lot of you got comments from me about line wrapping. Sometimes in your source code, you have these just gigantically long lines that go on forever and ever, and they wrap around to the next line, and then they wrap around to the next line. And I've discussed this a few times during the live stream / in lecture. That those are hard to read and they're hard to maintain. Generally, if a line of code doesn't fit easily on the screen that you're looking at, then you should chop it up. You will thank yourself when you have maintenance work to do in code, and I thank you for doing that because it makes my job of reading through, in a typical week, a couple of hundred different pieces of code in my various classes, makes my job just a little bit easier, which keeps me on an even keel and keeps me in a better mood. But also, it's just best practice. It is not good practice to just let things go on and on and on and just, well, I don't care wherever they wrap. Care that they fit in the screen. And if they don't fit in the screen, then chop them off and do a different print statement. Same goes for your output when your program is running. If it runs across the screen and kind of drops down to the next line and you just let that happen, don't do that. Chop it up in your output. So your output should fit nicely in the screen when it's running, and your code should fit nicely in the screen when you are coding or when someone's reading it. These are just best practice things to do. Code or program output that wrap around the screen, they look like someone didn't try very hard. Whether or not they did is not the issue. They create the impression that someone didn't care, that they let that happen. But they also just make life more difficult for your user who's running your program, for other programmers who either may want to or need to read your code. So that's just best practices to do that. I'll try to talk about what global variables are, but you will never in a million years see me use a global variable in this class, I don't think. And what I mean by a global variable is variables that are declared outside of any function. So a few people, because they didn't watch the lecture video is my guess, because I didn't do it that way, put their variables just sort of outside of any function, which is a convenience because then you can access those variables across all of your functions, but they are considered very poor programming practice. Good programming practice, best programming practice is you create variables inside of functions, you pass those variables to other functions as parameters, and you return values from functions to get data sent back to the caller. So use passing and return values, not globals, is best practice. And I say that in part because it would reflect poorly upon me as a teacher if I didn't say something. So in the future, if you use a global variable, you can say, yeah, Boyd at Butte College didn't want me doing that, but I'm doing it anyway. So at least you can say that honestly, that you should not do that. And I would never teach you to do that. Okay, what else about projects? Start early. So at the end of the live stream tonight, I'm going to start project 3. And I know a lot of you probably had a busy weekend or Sunday night kind of scrambling to get project 2 in. But it's the nature of some college classes at least, we're always kind of moving on to the next big thing. So our next big thing is Project 3. So at the end of the live stream tonight, I will begin my Project 3. And the reason I'm doing that is to encourage you to do the same thing. You want to start projects early, even labs if you can pull it off. You want to add to them over time and then refine them over time. So just to do good software engineering does not mean that you have to sit down and do the entire everything at once in one sitting. It usually means that you do a little bit, you go away from it, you come back, you do a little bit more. And as you're doing a little bit more, you're kind of cleaning up what you had already done before and fixing problems. You go away from it, you come back. So start early, add to your project, build it out over time, refine it over time, meaning fix bugs, fix bad display, fix wrapping code, make improvements where you can, fix bad calculations where you find them, all of that stuff, right? Over time, not just at one sitting on the Sunday when it's due. One of the benefits to starting early and kind of constantly having something that works, even if it's not everything that you want, is that you can ask other people to sit down and use your program and tell you about it. I find it's best if you get a non-programmer to run your programs, have them sit down and try to play your game or run through your program and get their reactions. So if they say, for example, I don't know what to do here, there's a good chance that there's something that you have failed to display on the screen to give your user instructions, just as an example. So if you start early, you can add more stuff and fix problems over time. And it also allows you the time to do testing, meaning you run your program and you try different inputs to see what happens, and also to have other people help you test. Ask someone else to sit down at your computer and run your program and tell you what they think about it. Are ways to get the best result. So there's my rant, I guess, about doing projects. Okay, that brings us to new content, which of course is always going on here, which is one of the reasons why I don't do late work, is because every week is something that builds upon the last week. Sometimes it's something brand new that still requires what we were doing in the prior weeks. So as you all know that you've made it this far, getting behind makes it very difficult to ever catch up. And none of you is behind. So we're in a great spot. I'm excited about Project 3 because you get some freedom on Project 3 to do what you would like to do with it. So I'll give you some tips about getting started at the end of the live stream today. So first, let us look at week 10. And make sure you can see what I see. Okay. So we're going to start using arrays this week. And all an array is a place where you can store many of something. So you can have arrays of integers as an example, which is really just saying a single place where you can store multiple integer values. But you can also have arrays of floats and arrays of strings. And what they allow you to do is manage more information in your programs with less code, which we love. So that's kind of always what we're looking for as software engineers, is how can I do more with less work? At least I am, and I hope you are as well. So arrays is our first kind of big step. I guess it's our second one, because functions are a way to kind of do more work, more things with less work, because we can capture what a function's behavior is and then reuse the function many times in a program without having to rewrite the same code over and over again. Arrays allow us to scale up the amount of data that we can deal with, and we can deal with the data efficiently. So we will look at what are arrays, how do they work, how do you make one in Go, How do you create them? How do you put data inside of them? And then how do you get the data back out? Arrays, one way to think of this is a collection, many computer scientists would call it. And by collection, we mean a single sort of container with many elements inside of it. A shopping basket is a collection of food items, as an example. Okay, so anyway, we'll go in and we will access individual elements. So just because you stored 10 integers in a collection doesn't mean that you still can't go get one specific integer that you want from it. So arrays give us the ability not only to sort of efficiently process everything, but they also give us the ability to go get individual items from the collection and deal with the individual items when we want to. We'll look at getting the length of functions, which is simply a count of the number of elements that are in an array. And then finally, we will go back to our loops. And the reason we're going back to our loops is because loops were made for arrays, or vice versa. So one great thing about arrays is that we can do huge amounts of work on huge amounts of data with very little code if we combine arrays with loops. So it's one of the great things about arrays is that when combined with loops, we can do a lot of processing with very little coding work. Okay, so a bunch of readings. I'm still not liking this new icon for the opens in a new tab because it blows up my formatting, but whatever. Homework as always. The lab I will open so I can come back to that later, but I want to keep it open because I want to stop on the reminders page so I can get at the project, which I'm sure is there. So what are we going to do in the lab this week? We are going to use arrays. We're going to create arrays. We're going to put data inside of them. We're going to use loops to process them. It's fairly repetitive because I want you to get used to what they look like, the syntax for arrays, and the processing loops that we write for arrays. I want you to get to grow accustomed to what those look like. So the lab is somewhat repetitive in that respect. Okay, so I have that open. The discussion. So the discussion this week is a poll just to kind of give you, well, for one, a break from the longer discussions where you're doing research, but also so that you have a moment here to communicate to me through this poll what concepts that we have covered so far that you find the most challenging. So it's an anonymous poll. You'll just vote in it. You can post if you want to, but it'll give me a chance to go back and look and see if there's any like, oh, goodness, everybody seems to be struggling with a particular concept. I can go revisit it. But anyway, it should be a break because you just go think a little bit about what concepts you have found most challenging and then make your vote, but no research. And then finally, reminders. So homework lab discussion as always, and then here is project 3. So I am going to open that as well. And that'll be later in the live stream. I'll probably put a break in before I do any project work so that those of you who want or need to go can take your break. Okay, so if I'm right, Shamar, you're asking, is there a unit test with the lab this week? And there is not a unit test this week. Hopefully that's the question you're asking. So no, this week's lab has no unit test. We're going back to what we were doing before unit tests, which is simply having a little program that displays the results of your functions. Okay, so good. That was the question you were asking. Yes, no unit tests for lab this week. It's all in one file. So you will be implementing functions, and then in the main part at the bottom will be calls to those functions. And what I'll do when I evaluate them next week is I'll click run, and the output should be the same for everybody because the lab kind of dictates specifically what is wanted, but no unit tests with it. So good question. let me get a REPL up and let's talk about arrays. Week 10 feels pretty good. Okay, so I'm just going to make an array. So there's an array. There are other ways to do this, as you know from, well, at least you can think of the fact that we have different ways of making variables. So arrays are a variable. The difference is that as opposed to what we're accustomed to, which is single values at a time, we are declaring variables that are capable of containing multiple variables at once. And in fact, this array, so this is the array, it's called numbers. It is a container or a collection for 5 integers. And we can actually inspect this array before we've done anything else with a couple of print statements. So let's do that. Now I have this var x here just as to remind you what regular variables look like. Regular variables don't go away. We still use int variables, float variables, string variables, but there will be situations where having a collection of things makes more sense. Initially, it will be because it makes sense, because if you don't do it, then you don't get the points for the lab. But you'll see in the third project, as I start to build mine out, that I will use arrays to manage a collection of information for my implementation. So when to use arrays, in other words, initially will be when I tell you to use them. Sorry about that. But over time, we'll start kind of watching for when the opportunity presents itself to use an array to store information. So here's my array. It's called numbers. It is going to be a collection of 5 integers. And let's look at it from the print perspective. So let's put a new length. And finally, all right, so here's an example, by the way. You see this line is kind of pushing it. This line is right at the maximum before I should chop it up into parts. As it is, it's okay because it's inside the screen. And I know I could blow up my browser to stretch across my giant screen here, but it's not a good idea. So generally speaking, we can see down here column 81. Column 80 is about the place that you typically want to stop. 81 is not going to hurt anybody, but it's kind of pushing it. So you get down around column 80 or 81, and hopefully everyone can see this here. That's about as far as you want to take a line of code before you split it up into more lines of code. So I am right, just barely sort of edging over the maximum. Okay, so let's just run this. And then I'll clean this up after you've seen it once. So one thing that we can get from Go is we can go and see how many elements are in an array. Now, why would we want to do that? I'll give you an example here in a moment of why we want to be able to sort of computationally get the length of an array. This is a length 5 array, and I can see that because the 5 is right here. But there are many situations in programming where it's not nearly as convenient to know how many items are in an array. So it's a good idea to get in the habit of computationally getting the number of items in an array. Should be 5 though. So 5, as we expected. I'm going to take this part of the message out, which is one of the reasons why I was okay with column 81. Now I'm stopping at column 54, and that is much better. Okay, so the length of an array simply means the number of items that are in it. We can also look at the array itself with a new printing verb, %v. So with %v, you can pass in an array, and then I'll show you what it looks like. It actually will show us, give us a sort of a visual representation of the array. If we look here, there are 1, 2, 3, 4, 5 zeros as expected. So that is useful for testing purposes. We rarely use that in real software, at least we won't in this class. But on labs and in other experimental situations, we will use this printing verb, %v, so that we can kind of see a rough representation of an array. Okay, so those are two fundamental things. We can get the length, which tells us how many elements are in it. If I change this to 3, hopefully everyone knows that changes the length to 3. Notice, by the way, I already get to enjoy my computational length. I changed this 3, but I don't have to touch anything else. So that's pretty good. Better. Okay, so now it's a length 3, and it has 3 zeros in it. Okay, what's next? Let me get my... Okay, so we did length. We created one, at least we created a 0 out one. All right, accessing elements. So let's do that next. So an array would not be very useful if you couldn't go in and access the elements. And this is one of the places where arrays cause people some discomfort. Because every element in an array, so if I put some comments here, so so I'm going to do this in comments and see if this doesn't help you. But numbers is a collection, and we can actually get at the individual items. We can access the array and target a specific element in it through what we call indexes. So we can get at the first element by using the array name and then using the square brackets and the index of the element. So every element of an array has its own unique index. What is off-putting to new programmers is that in the Go language, as is true for most programming languages, the indexes start at 0. There's a reason for that sort of underneath the hood, but I don't think we should worry about why it starts at 0. We should just contend with the fact that it starts at 0. But because it starts at 0, it has an important implication. So the second item, let me line these up. Hey, where'd it go? The second item is at index 1. This is true for every array, no matter what kind of data is in it, and no matter how big it is. The first item is always index 0. The second item is always index 1, and so on. So the third item I don't know if there's anybody out there who wants to. We'll see. I'll try it and see if any of the courageous people are in chat. So what's the index of the third item? Nice one, Kevin K. Index 2. So you'll notice that though they start from 0, the indexes just kind of go up one at a time. So there's no special code numbers or anything. No, that's good though. So Shamar, you So you anticipated my next question, which is, what is at numbers 3? But also, Shamar, I'm glad that you ventured the answer, because this is the other than looping, this is one of the more difficult things to get straight in our head, because we have been taught since we started counting to count from 1. And unfortunately, we have to learn to count from 0, but that does something to our counting. So to answer the question on line 18, you have to look at the code on line 10. And I will give you a hint. It is a trick question. All right, so that is right. So Shamar in chat, numbers 3 isn't anything. There's only space for 3 integers in the array numbers. And unfortunately, that means if we start the indexes from 0, which we have to because that's how Go works, then by the time we get to the 3rd element, which is actually only index 2, we're out of numbers. The collection, that's the end. So index 3 does not exist. Here's another one. This one's harder. But this is important, so I'm glad you guys are willing to venture the answers to the questions, because your answers help me kind of frame the discussion, because this is something new and it's weird. We call it zero-based indexing. But it's hard to get straight in your head at first, because this is a so that's true. So let's say it this way. What is numbers length? Numbers? Well, that is numbers at 3, which does not exist. So the length of the array does have a relationship with the indexes, but it is a weird relationship with the indexes. I'll say valid. All right, so here's the question this time, because you guys are getting warmed up. There is a relationship between the length of an array and its highest valid index. So the question here is, what value would I subtract from the length of numbers that would mathematically give me the highest valid index? Nice one, Kevin K. It's 1. So the highest valid index is always 1 less than the length of the array. Always 1 less than the length of the array. Why? Because the first index starts at 0, which throws all the counting off by 1. So because every array's first element starts at 0, every array's last element is actually the length of that array minus 1. All right, so there is some kind of just thought pieces about the array. So now let's actually go manipulate it. So one thing you can do when you target a specific element of an array, so I'm saying I want element 0 of the numbers array, is you can overwrite that with new data. Numbers is an integer array, so I'm just going to put 10 here. So I can actually target one element of the array and I can overwrite it with new data. And if I do that, let's just say now we'll use the %v trick to see if this had any effect on the elements in the array. Nice one, Kevin K. That's right. So there is the initial state of the array, which it's all zeros, and then here's the array after I have overwritten the 0th element, the first element in the array with the 10. So let's go ahead and I'll do a tricky one. Well, no, let's not do tricky ones yet. 20, and then numbers 2 equals 30, and then I will do an array is now. Okay, so I'll give chat a moment since we got some people warmed up on it. The one on line 28. What will it look like? 10, 20, 30. So that's exactly right, and we will confirm Kevin K's answer, which is a correct one. 10, 20, and 30. Let's try something harder. All right, so let's see if we can figure out what this one does. So the trick I'm using now is that I'm using one element of the array to do math on the right-hand side to produce a result that will be overwritten to one element of the array on the left-hand side. So you can use array elements in math just like any other element of that type, in this case integer. Nice one, Shamar. Oh, close. Yeah, so Shamar, you had the math exactly right. The trick was I put it over the first element. Yes. So in the Dan bars now, getting on track as well. So I took numbers at 1, which was 20. Now this is starting to get hard to keep up with, so I won't take this much further because you have to kind of, there's a lot going on anymore. So I take numbers at 1, which was 20. I add 5 to that, which becomes 25, and then I take that 25 and I overwrite the 0th element with it. So the point there is you can overwrite elements of an array, but you can also come back to them later and use them in calculations when that makes sense. Yeah, so I think for you guys in chat, I appreciate the work you're doing to help me out. And I know at this point, like this is starting to be probably about as much information as you can manage in your head on Twitch. So yeah, I know I pushed it a little bit. So you guys were good sports to work it out. So there's the result. We took the element at index 1, which is the middle element, number 20. We added that to 5, and then we took that 25 and we overwrote the first element with that 25. Crazy stuff. Okay, so there is an integer array. I am going to comment this out. I'm going to comment this out, and let's do a different kind of array. All right, so there's one way to create an array, is simply kind of a all zeros type of array. We also, though, we can shortcut these things, and we can say instead, for example, var, no. So we can also create an array in the shortcut style. We still have to say how big it is, but we can populate it with data at the moment that we create it, as opposed to just letting it be its 0 values. Maybe, never, always. So, oops, there's a piece of syntax missing here. These are 5 strings. So you also have this syntax, which lets you create an array and pre-populate it with data. So now instead of just being nothing, it has actual strings in it. Let's do the same experiment. So we will do a, what am I doing? Oh, length of messages array. which is simply an integer, and we get that computationally because that's the smart way to always do it. When you can do it computationally, do it computationally. And we can also do, for testing purposes, the quick %v to get the contents of the array. That's right. So Shamar, you are exactly right. Yes is at index 0, and yeah, so that's right. So Shamar in chat is saying, so this yes presumably is now the data at index 0. I would less call it a placeholder than the data that I have placed there from the get-go, if that makes sense. So instead of just doing one of these things where I have all empties, I have pre-populated it with data from the get-go. So yes, it is. So the index of yes is index 0. The index of no would be index 1. The index of maybe 2. The index of never 3. And the index of always 4, which it turns out is 1 less than the length of the array, because when you count from 0, when you get to the end, you're always 1 less than the actual length. So it is correct, Shamar, to say that yes is the value we will find at index 0. And let's do that right now. Let's print it, in fact. So the value at index 0 is, and here's a tricky thing, it's a string. Messages at 0, and Shamar will be correct that we will see yes print here. Look at all that. So the length of the messages array is 5, makes sense. If I do the quick kind of dump of the data, just for testing purposes, yes, no, maybe, never, always, that matches what I think it should be. And then, as Shamar pointed out in chat, the value at index 0 is that yes. So this brings up, though I'm glad you said this, Shamar, because it brings up another thing to talk about, which is the whole thing is an array. So you have to think plural and singular when you have arrays in hand. So the array is plural. It is 5 strings. But one element of the array, which we get by indexing, one element of the array is singular. It is 1 string. So notice when we print one element of the array, we use the %s printing verb, because messages at 0 is one of these, which is a string, singular. So this is a singular thing. It is a string. This v lets us kind of dump the entire collection so that we can, at least for experimentation purposes, see what it all looks like. Okay, so there's that. Yeah, okay, so there's a string one. So I'm going to do a float one. And I will do, let's pre-populate float as well. So let's call it, like, I don't know, temperatures equals. So let's just do a few. Or should we do a bunch? No, because I have to come up with them. 5 float 64s. And then I'm just going to make some up, right? So 73.5, 99.9, 86.7, which is like West Texas weather a little bit. So now if we print out the length of temperatures array, the lengths are just integers. It's just a count, which is why I'm using the %d verb here, because when I go compute the length of an array, I simply get an integer that's the count of the number of items, which it should make sense that that should be a whole number. I can also do just the quick dump of the data on the screen so I can confirm the contents. So temperatures, contents, So if I want to see the whole array at once, which is usually because I just am kind of debugging or testing, I'll use the print verb %v, which allows me to put the entire array name on there, and then it will spit out the thing with the square brackets around it. What was I going to ask, though? I was going to ask a question. I don't know. It'll come to me in a moment. Let's run that, though. Make sure that that is everything that we think it should be. Oh, yeah. Now I remember. Let's say the first temperature is... So... There's two sets of question marks. So let's deal with the kind of the easier one first, and then we'll deal with the harder one. So I think the easier one is this set of question marks at the end. What do I write there so that the print statement will target? Let's do the last. Let's switch it up. So what code do I need to write over the top of those question marks so that I see the last temperature in that array? And I'm glad I've got some sort of courageous folks with me tonight. Goodness gracious, it's almost 5. Nice one, Shamar. That is exactly right. Temperatures at 2 is the last element. And Kevin K also hit that one on the head. Temperatures at 2. So it's a size 3 array. And you just kind of have to train your brain to count from 0. So 0, 1, 2. Or you could say to yourself, well, the last element is going to be 1 less than the number of elements. The last index is going to be 1 less than the length. If it's a length 3, then the last index is 1 less than 3, which is 2. That's the other question marks. So that's correct. So Kevin K is filling in the other question marks, which is what's the formatting verb, which because this is one thing, a singular thing from a collection of floats, which means it is one float, which means the formatting verb is one float, and I could enhance it if I wanted to. Let's put 2 just for fun. So yes, if we take and index the array, then to format its output, we would format for a singular float. And there's our 86.70 as we expected. So nice stuff. But you guys are doing quite good with it. So I hope that's true for everybody. Okay, so phase 2 coming up, which is the processing part. So we've looked at creating arrays. We can create sort of a zeroed out array, which is what we did with the integer array, or we can create arrays that are pre-populated with data. Our choice based on our needs. And then we also looked at how do you get the length of the array, how do you index or use indexes to access the individual elements of the array. We made note of the fact that the first element is always at index 0, which takes some getting used to. And the last element is always the length of that array less 1. Why less 1? Because we started counting from 0. Same thing, right? If I just say, give me 10 numbers starting from 0, well, you'd go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 numbers, even though you stopped at 9, which seems not like 10 unless you account for the fact that you started at 0, which means that you stop one short of the total number. So those things take getting used to. All right, phase 2, which is I'll leave it on the screen, Shamar. If you're getting an error message, then probably there's a mismatch somewhere if you're kind of following along with me. So I'll leave this on the screen for just a moment so that you can inspect that. All right. So, but I am going to start setting up for the next segment is this is all fine and good, and we need the ability to get the length of arrays. We need the ability to target specific elements individually inside of them. But very often, one of the reasons why we like arrays is because we can do kind of batch processing on them with loops. And I'm going to do one right now. So loops and arrays were made for each other. So learning how to write loops to process arrays is a super, super, super handy skill to have. And I'm about to do one. So I'm going to do a counting for loop first. Print all temperatures. And this is going to take some getting used to. I'm going to write it and then I will explain its components. So this is where we start enjoying the power of arrays, sort of acknowledging the fact that it is hard to learn how to write these loops at first. So you've seen loops, and now we're seeing one of their more powerful applications, which is doing things in batches on arrays. Okay, so this is a counting for loop. So we talked about counting for loops before, and now we're using them in a slightly different way. But here's what's going on here. I'm using an I. So I is my counter. Why do so many programmers use the letter I in this kind of a situation? And maybe someone in chat can answer this question. I is a very popular name for this particular situation. We use I a lot because it happens to be the first letter of what we're using it for. So we're using I as a stand-in for some part of array access. I don't know if that question made any sense. Iteration is one way to think of it. So iteration is appropriate. We're going to do a certain number of iterations. So I is the first letter of iterations. That's true. We're going to do the same number of iterations as there are elements in our array. What's the other word that we've talked about associated with arrays that starts with I? Integers, that's true, although this is a float array. So let's keep searching our increments. Keep going. These are all appropriate, by the way. Maybe I'll give you a indexing. Shamar got it. Index. So you'll see most programmers, in fact, will put an I for this counter. You can think of it as representing iterations or increments, but you can also think of it as I being the stand-in for the index. So why would I start the stand-in for the index at 0? Because arrays start their indexing at 0. So this I is going to stand in as an index value starting at 0. Why? Because that's where array indexes start. It's going to stop. Notice it's a less than, which means it's going to stop one short of the length of temperatures. And why is it going to stop one short of the length of temperatures? Because the index only goes as far as one short of the length of an array. So this piece of logic here says I don't go stop one short of the length of the array, which is what we want indexes to do, is be one less than the length of the array. And then we do, this is the incrementing part. We count up one at a time because that's how array indexes work and go. So we start at 0, then we go to 1, then we go to 2, then we go to 3, and we stop one short of the end of the array. So for our array, we're going to start at 0, we're going to go 1, 2, and then we're going to hit 3, and that's going to be too big, and we will stop. So that's what the counting loop is doing, is it is actually giving us the indexes cycling or iterating across the appropriate index values. 0, 1, 2, stop. And then what do we do with the index? We actually use the stand-in, the counter, to be the index. So when I is 0, we get the first element. When I becomes 1, we get the second element. When I becomes 2, we get the third element. And when I becomes 3, the loop stops because it's out of indexes at that point. So let's do it. So there they are. We can, by the way, use the I separately. So we could say, let's include the I in the output so that we can actually see the indexes as they go by. So we'll actually use the index variable, which will start at 0, then go to 1, then go to 2, then stop, at the same time that we're using it to actually index the array itself. So there's temperature at index 0, and then we also use it to actually get in the array. Index 1, and then we use the I to get in the array. Index 2, we use the I to get into the array. Very, very, very powerful. Uh-oh. There we go. Okay, so I'm leaving all this behind because I'm going to share the link so that people can get to it later. All right, so let's set up another one and set up another counting loop and fiddle around with it a little bit. So let's go back and we will say our favorite colors. I got to come up with 5 colors here in a moment, so maybe you can help me in chat. So this is going to be a zeroed out array. We can prove that, by the way, by doing the debugging print. So to start, we'll use the %v here so we can show the whole array with nothing in it. So there you go. Now it actually has 5 empty slots for strings in it. But let's use a counting loop in combination with some user input to actually populate it. So here we go. 4. You're going to see this pattern a lot, by the way. I equals 0. On the next one, I'll ask chat to help me fill in the blanks. I is less than the length of the array I want to process. Count up I 1 at a time, because that's how the indexes count up, is 1 at a time. So starting the indexer at 0, going up 1 at a time, stopping 1 short of the length, because that's what you always have to do, because the length is 1 too many in terms of indexes. But let's have some fun with it this time, and let's let the user type some stuff in. So enter color number, and we'll use the I. So we're going to use the I just to say, hey, enter color number 0, color number 1. So the I, since it's just a regular old integer, can be used for dual purposes. It can be used to kind of show what index we're on in our output, and then it can also be used to access the array itself. So we're going to scan. We're scanning a singular element of the array. And then we need the ampersand, but the array itself is called favorite colors, and we are indexing it to work on 1 element at a time. So we're going to say, give me color 0, color 1, color 2, color 3, and then we will scan those in and scan them directly into the array itself at the index that the loop is giving us to use. And then when we're done, we'll print it out and see if our colors got in there. All right, so here we go. So I've got a program running. So enter color 0, red, green, blue, yellow, purple. I know that this is going to stop because this is a size 5 array, which means the last the last index is 4, which will then we'll stop after this because this is the last one that's still one short of the length of the array. And then when we print it out, we notice that it did in fact put my colors in the correct order from 0 to index 4. So there's a lot of things we can do with arrays. I'm going to show you one more trick here. Don't get too hung up on this. I'm going to copy this. And I'm doing this in part because I want to leave this here as a breadcrumb for you for later. So when we are writing software for humans, think people who aren't software engineers, most people are not accustomed to counting from 0. So when we're writing software that needs to show these index numbers, we will often do this little hack to trick our user a little bit. So I'm just going to, for the purposes of the display, I'm going to tack an extra 1 onto I. That means when I is 0, it'll look like 1 on the screen. And when I is 1, it'll look like 2 on the screen. But I'm not changing what it's doing inside of my code. So this little hack we use a lot. It's a hack that we use only to show stuff on the screen. You sort of just imagine any person you know who's not a programmer, and you say, okay, I'm going to have you run my program and enter 5 numbers, and then they see, well, enter color number 0. They're going to be a little put off by that, or at least they might. So we do this little hack. It doesn't alter I, it just makes it look 1 more, but it doesn't make it 1 more. It just makes it appear to be 1 more. And then when our friend or acquaintance runs our software, they're like, oh, color number 1, I get that. Red, yellow this time, 2, green, blue, purple. So as far as the normal human running my program thinks, I just entered 5 colors. We know inside of our software that, well, what you actually did is you entered the color for index 0, the color for index 1, all the way up to 4. But I tricked you and made you think that you were entering color number 1, even though I know inside my software that was color at index 0. And there's the end result. So I'm just showing you this little hack because we use it a lot when we are making programs for normal people to run. All right, so that is a counting for loop for my colors array. Okay, so let me comment that out. And now let's do, I'm doing okay on time. I'm not doing great on time. So if you look on the agenda, it says new range for loops. And there's a little star that says ignoring I. So what in the heck is all that about? So there is one more kind of loop in Go that is even better for doing arrays than the counting for loop. So I'm going to show you the other way of doing arrays with a loop, which is the last kind of loop that I think, it's probably the last kind of, it's the only other kind of loop we haven't done. So there's one more kind of loop. It's called a range loop, and we're about to use it. What are we going to use it for? I don't know. I don't know. That's fine. I'm keeping these numbers small, by the way, just so I don't have to spend a whole lot of time making stuff up. So let's just do an empty one. Yeah, you know what I'm going to do, in fact? Let's put random numbers in it. So I need math rand and time for this to work. So let's see, is it rand.seed time.now.unix. Nano, I normally don't remember that. But now we can populate our array with random numbers if we want to. So let's do that. New kind of loop. The range for loop. It was purpose built to do arrays, but it looks funny. So it's a little bit cleaner than a counting for loop, but it's also new, so it might be confusing at first. Range is built into the Go language. So what this is kind of trying to tell us is that we are going to range over the numbers array, which means step through it one element at a time. But at least that's how I read it. So this whole thing, the purpose of it is to sort of semi-automatically step through every element of an array from start to finish. As we are stepping through, we can capture the index of each element and the number at that location, which will be a singular integer. So I is the index, n is the number. Where are those coming from? This built-in range thing. It will automatically step through the numbers array, giving me each pair index value until from the beginning to the end. So we'll start just by using it to print out the contents of the array. So let's do a format.printf before populating with random numbers. So we're just going to print out each one. Just not going to put new lines in front of them. So we're going to get the... Ooh, let's do it with little square brackets around it, which could look kind of fun. And the number itself, which is also an integer. No, I'm going to put new lines. Okay. This is hard, but once you get used to it, it's pretty powerful. So what am I doing here? I'm getting pairs of indexes and their associated values that range automatically gives me. So in the square brackets, I'm going to put the index I get, and this other %d will be the number. I'm just calling it n, the individual number I get at that index. These are automatic, so they're not easy to see what's going on because it's invisible to us. How does this work? This range thing does it automatically. Gives me the first pair, index and value, the second pair, index and value, the third pair, index and value. So this should have 5, the 0, the 1, the 2, the 3, and the 4, and they should all be zeros to start. Let's see if that's true. So they are all zeros to start. And notice it stopped automatically. So at index 0 was a 0, at index 1 was a 0, and so on. Now let's use a range for loop to populate the array. So we'll just reuse this same stuff. But instead of, that we'll do it both directions. It's fine. So this time, instead of printing them, we're going to populate the array with a random number. Let's just say a random number between from 0 to 99. So we're going to use the range to grab this I, which is the way we index the array and put new data inside of it. In this case, we're not actually using the n, but I'm going to go ahead and run it. And hopefully we see an error and I can then explain the error. So notice it says on line 21, n was declared and not used. So this is what the ignoring thing is talking about. And I should probably enhance the note to say ignoring I or So I'm getting an error because I have this end and I'm not using the end in any of my processing. And Go doesn't like you to do that. So if I don't need the end part, I can simply use an underscore to blank it out. I have to give space for it, but I can use the underscore to tell Go that, yeah, I know there's an end, but I don't need it right now. In which case, when I run it, I'll get no errors this time. So we can ignore one or the other part, either the index or the value when we range a loop. I'll ignore the index next. So let's do another range for loop. I'm going to range over the same loop, except we want to say this time printf after populating with random numbers. Range over numbers again. This time we're just going to print the numbers side by side on the screen. So format F, put a %d and a space in there, and then put the number. So I use a range loop to print out the initial state, the indexes and their 0 values. I use another range loop to put random values at every index in the array. And then I'm going to use a third range loop to print out to see what my random numbers look like. And I'm going to get an error on this one as well. Okay, so now it says on line 27, I have an I that I'm not using inside of the loop. So what do I do with this I, do you think, chat? Nice one, Kevin K. I underscore it to signal to Go that I don't need it. So perfectly legal. So this time I only care about the number part. I don't care about the index part, so I'm going to ignore it. And that should show me my random numbers. There they are. I didn't put a new line at the end of that. But I got 68, 38. And if I run it again now with the new line, there'll be different numbers because I am seeding. So there you go. That's range loops. Takes a lot of practice. Let me grab the link to this and make sure that I don't forget to share the notes repo with you. All right, so I'm going to page 2 now of the agenda. So I'm going to do, I have time before 5:30 comes, I think, to kind of take a quick look at Lab 10. So I will share all of what I just did with you. The week 10 lab, I'm going to try to not share with you because I don't want to just constantly give you answers and then you don't have to stop and thoughtfully work through any of these problems. But I do want to look at it together before we do that. So let me fire up a REPL for that. So CSCI 20 lab 10. And let's look at the code and let me give you some tips. But heads up, the lab tips are not getting posted. This is sort of just video only thing. So there's 20 elements in here. And I'm just going to give you some tips. Of course, the documentation is always counts for some. So anyway, hopefully everyone's got that. The lab tips are video only. So please get the word out if you know people who aren't in the habit. They're here. They will be in the video when I post the video, but I don't want people to just kind of copy and paste code constantly. So let's look through the lab. Shamar very helpfully brought up the question. Oh wait, sorry. There's a question in chat here. Could you just not do it and put for I or for N? I'm not sure if I understand the question exactly. So maybe Kevin K, you can help me with the question about the underscore trick. Right. So I do have, um, so in the first example, I have I comma underscore because I'm ignoring the value part, the n, which is the number itself. In the second example, I'm keeping the number but ignoring the index part, so I underscored the index. But they're separate. So the I is the index and the n is the value at that index. They're different pieces of data. So the first one, the I, is the index itself. The second one, the n, is the value at that index. So you can ignore the index because you only want the value part, or you can ignore the value part because you only want the index with the range loop style. So hopefully that addresses that question. I'm not sure if I did, so we can keep working on getting a better answer for you if it's needed. Okay, so there's no unit test in the lab this week. The whole lab is in this one main.go file, and I will be examining the output of the lab to see if it was done correctly. So what does the lab look like? It is a series of explorations of arrays of different types. So number 1 says declare an array of 10 integers named numbers in its zero state. Zero state means that it has no initial data associated with it. So an array of 10 integers named numbers, which is 10 integers, that's what that would look like in its initial state. Then it is explicitly telling us to print it out using the %v trick so that we can see a representation on the screen. Then it is asking us to print the length of the array, which we've done. Now number 4 says, notice there's no mention of a loop here. It says use array indexing to individually populate the array with values 10 starting in index 0, 20, 30, all the way up to 100. 10 separate lines of code. So what do we mean? Well, it means go to the numbers array, hit index 0, write a 10 there. Go to the numbers array, index 1, write a 20 there. Yes, we could use a loop here, but I want you to get the practice and the repetition of the individual access. Then we do a whole bunch more of those. And then finally, we use %v again to see that the data that we individually populated the elements of the array in are in fact there. So int array makes no mention of a loop, meaning there should be no loop here. Float array, let's see what it does. An array of 5 float named scores in 0 state. Scores 5, 5, float 64. A counting loop. So a counting loop is one of these things. So when we say counting loop, we mean the whole mess with the I equals 0, the I less than something, the I plus equals 1. Prompt for and read in values. So that's going to look like this. F, enter score number. And why not be fancy about it and use the I to say score number 0, number 1, number 2. It'll go up to 4. And then we will scan in a float. So scanning in a float and storing it. Need the ampersand or this doesn't work. Still, even with arrays, the scan needs the ampersand. Putting it in scores, and we are going to use the index that the loop gives us to pull that off. So that's number 7 actually complete. Unless you want to do the cool hack where you make the number on the screen look like one more than it actually is, in case a normal human runs your program. Up to you. All right, so there's a counting loop, has the 3 elements in it. It's not a range loop, so there is no keyword range in here. If it says counting, then no range. Number 8, use %v to print the array. Easy enough. Aha, number 9. Use a range loop, ignoring the index part, to compute the sum of the scores. So how do we do such a thing? Well, we're going to need a place to hold the sum. If we add all the scores together, we're going to get one thing, one sum. So we need a place to hold that. Let's use a range loop this time. So for I n equals range over scores. And we're simply going to accumulate all the n's, which is the value part of each element of scores. Now it's telling me explicitly ignore the index part, so I'm going to do that. But notice inside the for loop, the index part, that information is not being used, just the value information. Print the sum of scores to 2 decimal places. That's simply this computed sum. Compute the average of scores. I'll let chat help with this one. I'm not posting this code because it's too much solution, but it'll be in the video for review purposes. The average of scores, fair enough. In fact, let's do it the quick way. Equals the sum divided by something. So I may not ask any more questions of chat today, but won't be I. So this is a tricky one. How do we get the average of those number of scores? So we want to get this denominator computationally is the hint. I'll show you scores. So what should we divide the sum by to get the average of those 5 scores? Five. So 5 is the correct answer. How do we get that 5 computationally? How do we get a 5 here computationally without having to code the 5? Nice one, Kevin K. The length of scores. So you want to get in the habit, when you can, of using the length when you need to know the number of elements in an array, for example, to compute the sum of all those values. Use the computational style. So try to avoid hard coding values about your arrays where possible. So the sum that we computed by adding all the scores together divided by the number of scores, which is the length of the array, will give us the average. Pretty cool. Okay, so that's the hints about that one. Hopefully they're sitting on the screen long enough to pause video on it later. Okay, so here's one. It says pre-populated. Fair enough. So pre-populated, greetings, equals a 3-string array that is pre-populated with hi, hello, and howdy. Use a range loop this time. All right, so that's one of these. I and n, range over the greetings. So this time the value part is a string. The I is still the index. But notice here, it's suggesting to me that it wants the index also the value part. So let's try it out. I'm not actually going to run it, but it would look something like this. So we want the index part, oops, which is an integer, and a space. So the index part will go inside the square brackets. The greeting part, which is one of those greetings, is a string. So we'll use I and we will use N. By the way, these labels, I and N, don't have to be that. We can actually call this G, or we can even spell it out. But we could, if it makes more sense to you, to say, you know what, the value part I'm going to call G for a greeting, and then we'll use that instead. Totally up to you. I and G, the I is a convention because it represents the index. The G represents one value associated with one index. So you could call it a singular greeting. You could call it the value part if you wanted to. I'm going to go ahead for the sake of consistency and just keep it as the n. So notice in the loop, I'm using both the index part and the I part. The puzzle I will leave you with here is, it says in the example, is there one more? There is one more. Yeah, I'm going over, I'm sorry. So the puzzle for this one is, the example says it's great if you can, wait, did I put them out of order? Well, it doesn't matter. It doesn't say they have to be in a particular order, but the example says it's cool to have 0, 1, and 2 as indexes. It's cooler to have 1, 2 as 3 show on the screen. So I'm not going to do it, but the hint here is the hack that we use to make the index look like one more than it actually is, so that normal humans. So the %d is how we make this 0 show on the screen. So square bracket just shows square brackets on the screen. The %d is populated with the value of I. So for our 3 string array, I will be 0, then it'll be 1, then it'll be 2. So we put the I in between the square brackets, which is how we get 0, 1, and 2. The %s following the space is how we get the value part from the array, which will be hi, howdy, and hello. So yeah, this will take some time to study and ask yourself, and ask me why the square brackets with the %d. Well, the %d I know is simply whatever the first thing is, which is this I. So I'll kind of prepare myself for that when I run the program and see what happens. The %s is whatever the n is, so I'll prepare myself and then study up on what range loops do. Give yourself time to get accustomed to this. Okay, there's one more. Parallel arrays. So I'm going to do this one, but it's only going to be screen, not giving you the code. Declare an array of 5 string named products that is pre-populated. Fair enough. Products is a 5 string array, has bread, milk, eggs, butter, sugar in it. Fine. The second one, number 16, says, oops, I'll go down here and do that. Number 16 says, declare an array of 5 float 64 named prices with some reasonable prices for each item. Fair enough. So prices is a 5 floater array. Bread. So the trick here is that the prices array goes up alongside the products array. So the first price in here will be the bread price. The second price will be the milk price. The third price will be eggs. The fourth price will be butter. The fifth price will be sugar. So bread, I don't know, to be honest. Milk. Eggs. These don't seem completely I don't know. That's probably fancy butter. $6 even. Sugar. I don't know. Let's say I'm $8.97. So when we say parallel arrays, we tend to mean 2 arrays who have information that line up with each other in parallel. So the first element of prices, 325, will line up in parallel with the first element of products, which is bread. The second element, 499 of prices, lines up with the second element of products, which is milk, and so on. Okay, so number 17 says use a counting loop, not a range loop, to print the products with their prices. So we're going to have to get a product and a price all at the same time. So let's do a counting loop. It's always going to look something like this. I less than the length of something. I grows by 1 each time to print some stuff. So the trick here is we have two arrays of the same size operating in parallel. Product 0 and price 0 go together. Product 1 and price 1 go together, all the way up to product 4, price 4. So here's my counting loop. The length when we are processing parallel arrays doesn't really matter. Either one of them is fine because they are the same length. So we'll just use the length of products to control our counting loop. So how do we print out bread, colon, space, $, price? Well, bread will be a string, colon, space, $, price will be a float, $, price will be a float. Since it's money, we'll go to 2 decimal places. Put a new line character. So where does this string come from? Comes from the products array. We need an index to get one of them. Well, the whole purpose of the counting loop is to give us our indexes. Got it. What about prices? Well, that's where the float comes from. What do we index? The same index that we get the parallel product from. So when the I is 0, we will get the product at 0 and the price at 0. When the I is 1, we will get the product at 1 and the price at 1. When the product is 2, product 2, price 2, and so on. So clever little trick to collect multiple pieces of data in parallel that go together, right? So the products and the prices go together, which means that we can print them out, the two pieces of information that go together. I'm going to give you a hint because this has an example and then it says this would be better. So the better would be what? I don't know what happened. Hopefully I didn't break anything. The better would look like this. So if you put a number in the formatting verb, experiment with that to see what happens is my tip to you, which I think I also put in my agenda. Yeah, enhancing formatting verbs. That's line 42. And I'll leave that for a moment. So what's going to happen here in a moment? So you don't have to stick around if you don't want to, but the video will be made available to you. I'm going to take a 2-minute break, and then I'm going to go start up some project 3 for myself. So I'm going to put a screen on that says be right back so that if you're watching the video later, you can just scan forward quickly until you get to it. Or stop when you get to it if you don't want to see it. Okay, but that's all a lecture, and thank you a bunch if you managed to stick around and hang with me for that long. So, there are hints for the lab. Hopefully you had a chance as I did these pieces. If you're watching the video later, you can just pause on that moment and see what I did, and then, back and forth, however you want to do that. But I do want to start getting us in the habit. I want to start cutting the strings, as it were, and giving you more time to sort of develop the code on your own without just sort of copying and pasting it. So we're going to up our game a little bit. But I don't want to leave you completely hanging, which is why I showed you these examples. So don't forget, there are 20 items in here. So there are 3 function calls at the end to complete the lab. Those are easy function calls. Int array has already been done as an example, and then it asks you to call the other 3 that you implement. What else did I have to say about the lab? So Canvas Inbox. Piazza, I highly recommend Piazza so that your classmates can share in helping to find solutions to your problems and seeing the solutions that were gotten to your problem. So you're doing your classmates a huge favor if you use Piazza. My rule of thumb on Piazza for labs is try to stick to one function at a time. So if you're going to post because you're stuck on one of the functions in the lab, then just post on that one function and let's focus on that post in one function. If we get posts on all the functions in the lab because people get stuck somewhere, that's okay. But at least we're having a chance to kind of separate out the discussion. So that's my recommendation about Piazza. And then, as always, office hours, which are not highly utilized, but some people have gotten in the habit of visiting, which is nice. And you can always drop in, schedule one-on-one time, or drop in on the open come and go time. Okay, so a short break's about to happen. And then I'm going to do a very quick kind of just look at project 3 and then spin up a tiny little starter piece that I can build up over time. So if you got to go or you're worn out at this point, that's fine. It'll be there on video, and you'll have this screen to tell you where this point happens. So be right back screen, and it's 5:46. So at like 5:48, I will have time to go fill up my water, and then I will do that. So anyway, thanks for being here. Thanks for interacting on chat if you were here, and if you're welcome to stick around for this next part. Maybe you can get up and stretch your legs and get some water as well. Now it's 5:47, so I'm going to say 5:50, and then I will be back. So short break, 5:50, about 10 minutes of having a peek at project 3 and doing a little kind of teaser about one way to go about it. All right, so thanks for sticking around if you could. Hopefully you could use a few minutes break. My voice is starting to wear out, so I'm gonna try to make this be inside of 10 minutes. But I do want you to start thinking about Project 3, and I'm gonna show you kind of just a few different ideas for how you might go about it. So I will be back here doing this exact same thing next week and the week after probably. where I show you Project 3 and I say it is a text adventure. Why a text adventure? Because we program in plain text. That's in part because we're limited to Replit, which only really, well, it can do more than that. But basically, when you're learning programming, dealing in text is the easiest way to go about it because you can focus on the fundamental techniques and not worry about graphics and all that stuff, which is hard to do, by the way, like windowing things. Anyway, so text adventure. If you haven't played a text adventure, I have put links here. Hopefully they're all still active. You can go kind of try out some text adventures and see what they feel like if you've never played one. We're not going for works of art here. So you do not have to fret if you don't think that you are a super creative person. We are a technical class. We are developing our technical craft in programming as a tool that we use in computer science. So that's the thing that I focus on. But some of you might find that you enjoy the project more because you have the freedom to develop a game and to develop some story and do some things that you find fun for yourself in this project. If you're just worried about the technical aspects, that's fine. You can do something simple and basic and straightforward and just kind of hit the technical requirements. But anyway, I highly recommend if you've never done it to go try a text-based game just to get a feel for the kinds of things you can do with them. We'll come back to the requirements. So for now, what I'm going to do is I'm going to go quickly show you a starter kit kind of for one way of doing a text adventure game. So I'll just call that P3V1. So one way to do a text adventure game, which I consider to be, personally anyway, I think it's the most straightforward way to do it, is to use what I call the hub and spoke model. We actually did hub and spoke in Project 2. So the hub is the main menu. Pick the game you want to play. And then the spokes are the individual games that you can go play. So if they picked item 1, they went out on the number guesser spoke. And then they were brought back to the hub. And if they picked item 2, they went to the rock, paper, scissors game, spoke, and then were brought back to the hub. We can do the same thing for a text adventure game. So I'm just going to spin one up real quick. And then I'll shut down. So, welcome to... Crazy Cave. I don't know. For loop. So that we can... the for loop is really what makes the hub, by the way. It's what allows the kind of hub kind of pulls you back. Is this for loop. But anyway, same as we did in the last project. We will have some locations. Perhaps I'll use a character this time. So I'll say pick a T for the treasure cave. I don't know. Adventure. Crazy caves. Pick an A for the adventure cave. Pick an M for the mystery cave. I don't know. Something like that. And then we could say exit. Let's say quit. So these are my spokes. The quit game really isn't, that just quits the game, but mystery, adventure, and treasure cave, those are the spokes. This main is my hub. So let's prompt them for an input here. Where do you want to go? We need a choice, which would be a string in this case, so they can type the letters in. We will do a scan for that string. Make sure that ampersand gets, and then we will do if choice equals big T or choice equals little t, just to be on the safe side. And then I'll just go ahead and sort of handle all the possibilities here. Is big A or choice is a little a, just in case. Else if choice equals a big M or choice equals a little m. And then only one other possibility really, which is what they wanted to quit. I guess I could do little q. Anything else is bad, and I'll just complain at them. Okay, so here's my hub. My spokes are going to be functions. So treasure cave. We have the adventure cave. Mystery cave. So there's my starter. These are my spokes. The mystery cave is a spoke. The adventure cave is a spoke. The treasure cave is a spoke. And my hub is in main. So let's connect the spokes. So T means treasure cave. Hopefully you recognize this from the second project, which is very similar, but in this case, there's no requirement in terms of what story you tell or what theme you use. We'll be adding some gameplay. For now, we're just kind of getting the basic flow of the game, the basic map kind of worked out. Adventure cave. Mystery cave, and then this one was quit, so we'll say thanks for visiting Crazy Caves, and we will break the nearest loop, which is the hub loop. So there is a basic kind of hub and spoke. I'll share this link as well. I made it private. I will undo that so I can share the link with you in case anyone is interested, which you may not be, but I'll still share. Public. Okay, so let's run it just to make sure that it is in fact a navigable hub and spoke. Here's my hub running. Try a little t. Took me to the treasure cave and then came back to the hub. The adventure cave, that works. The mystery cave, that works. Quitting the game. Anything else? That's invalid. And then quitting the game. Thanks for visiting. So there is a little one way, just one way of several that you might consider doing Project 3 is as a hub and spoke style text adventure. It's one of the easier ways to manage a map is just have spokes coming off a single hub, which is what main can be. I'll also attempt to implement more of a grid style map and see if we can pull that off. But anyway, it is 6 and that gets me to everything I wanted. So on the lecture page, I will share the beginning of the lecture example code, and I will share this Project 3 hub and spoke idea. The thing that I'm not sharing is all of the solutions to the lab, although those can be viewed on the lecture video. So anyway, thanks for sticking around, if you could stick around. The time to start Project 3 is sooner than later. The turnaround this time is When's it due? November 20th. So about a month, a little bit less than a month, the weekend before the week of Thanksgiving. So anyway, if you want to leave yourself plenty of time to think up ideas, to experiment with things, to encounter obstacles and get mine and your classmates help to overcome those obstacles and try out maybe some of the cool things you saw your classmates do in Project 2, then the time to start would be sooner than later. This one can be fun, but again, you are not pressured to do any work of art. This is a technical project that allows the space to be expressive and creative if you would like to be, but it's not required. If you read the requirements, you will see nothing in here that says it better be awesome. It just needs to do the technical things. That's our focus, with the freedom to do whatever interests you in that project. Okay, so I better stop. My voice is I can feel it's about to give. So thanks for sticking around. Thanks for being here, and thanks for chatting. For those of you who have drummed up the courage to do so, I know that's not an easy thing to do when you know other people see it. So thank you for that. Otherwise, I hope you have a great week. Canvas Inbox, Piazza, office hours for assistance on the lab. Or if you want to kick around ideas about Project 3, then we can do that there as well. So have a great night, have a great week, and I will see you on Tuesday next week.